Okay, and again, we're checking for symmetry with respect to the x-axis. So I've replaced my y with negative y, just like I have up here. I've multiplied both sides of the equation by -1 because I want to see what this equation looks like with y by itself. So I've got y equals negative x squared plus 9 over x squared plus 2. And I need to say, does that equal the original equation? So does that equal x squared minus 9 over x squared plus 2? No, those are not equal. So no. This means it is not symmetric about the x-axis. It is not symmetrical. Okay, let's check for symmetry with the y-axis. And checking back here, if we want to check for symmetric with regards to y-axis, we replace the x with a negative x. So anywhere there's an x, I'm going to replace that. So coming back to our original equation, I have y equals x squared. So that x I'm going to replace with a negative x and square it. And I'm going to do the same thing on the denominator because there's an x there. So again, replace x with negative x, square it, plus 2. Now let's simplify that. Negative x squared, that means negative x times negative x. Negative times a negative gives me a positive. So that gives me a positive x squared minus 9. Likewise, in the denominator, negative x times negative x gives me a positive x squared plus 2. Is that what we started with? X squared minus 9 over x squared plus 2? Yes. This tells us, thus, it is symmetric with regards to, or with respect to, the y-axis. So this equation is respective across the y-axis, the same thing on both sides. Finally, we want to check for symmetry about the origin. And to check for symmetry around the origin, we replace y with negative y, we replace x with negative x, and then see if the ending function is the same as what we started with. Okay, so first thing I'm going to do is replace y with negative y, replace x with negative x, and x with negative x in the denominator also. Okay, now we've got to simplify that to see, is this the same as what we started with? Okay, so we'll leave this negative y here while we work on the right side. Negative x squared, we've already done that. Negative x times negative x is positive x squared minus 9 over, again, positive x squared plus 2. I need to move the negative away from here so we can see if the equations are equal. I do that by multiplying both sides of the equation by -1. The negatives cancel on the left, giving me y equals, let's put this up here, -1, that's really -1 over a positive 1. So -1 times x squared is negative x squared plus 9 over x squared plus 2. That is not equal to what we started with, which was x squared minus 9 over x squared plus 2. Okay, so thus, it is not symmetric around the origin. Okay, hopefully that makes sense. Again, if we're checking for symmetry regarding or around the x-axis, we replace y with negative y. If we're checking for symmetrical around the y-axis, we replace x with negative x. Finally, if we're trying to check for symmetrical around the origin, we replace y with negative y and x with negative x. Okay, let's turn over your papers and we're going to do some examples here. I've got 3 different equations and we want to find we're going to graph them first of all by hand. We're going to find the intercepts and check for symmetry. Okay, so graphing by hand. The simplest way to do this is make a little table. So our x's and our y's. We're going to put in a couple of points. Let's try -2, -1, 0, 1, and 2. Negative 2 cubed gives me negative 8. Negative 1 cubed is negative 1. 0 cubed is 0. 1 cubed is 1, and 2 cubed is 8. So if we were to graph this at this point, let's see, it's up here. And hopefully you remember this is our cubic function. So it looks something like that. It kind of flattens out right there. There we go. Okay, let's check for our x-intercepts first. And remember, to check for x-intercepts, we set the equation equal to y. So 0 equals x cubed. If I want to find what x is, I take the cubed root. So cube root, cube root. The cubed root of x cubed, those cancel, giving me 0 equals x. And we know that. Right there is our x-intercept. This is also our y-intercept. Let's do it algebraically. If I were to look for a y-intercept, I set the equation equal to, or I set x equal to 0. So I'm going to substitute in a 0 and solve for y. Now this gives me obviously y equals 0. So my y-intercept is 0, 0. Likewise, x-intercept was 0, 0. Okay, let's check for symmetry now. So we're going to check for symmetry about the x-axis first. So if it's checking for the x-axis, that means I replace y with negative y. And I'll just write that y is going to be replaced with, sorry, I did that the opposite way. I'm going to put negative y in wherever there was a y. So what that equation looks like, y equals x to the third, it's going to be negative y equals x to the third. And now I want to get this y by itself and see if this resulting equation looks like the original equation that we started with. Okay, so the way I get rid of that negative is multiply by both sides by negative 1. The negatives cancel, giving me y equals negative x cubed. Well, that's not the same thing as positive x cubed, so it is not symmetrical around the x-axis. Let's try the y-axis. Is it symmetrical around the we're So if we're checking for symmetry on the y-axis, we take negative x to replace x. So again, I'm going back to my original equation. Anywhere there was an x, I'm putting in negative x. So y equals negative x cubed. If I want to see what this looks like, so negative x cubed is the same thing as saying y equals negative x times negative x times negative x. This gives me y equals, negative times a negative is positive, so that gives me a positive x squared times a negative is just negative x cubed. It is not symmetrical about the y-axis. So again, when we're checking for the symmetry on the x-axis, we replace the y with negative y. When we're checking for symmetry on the y-axis, we replace x with negative x. And finally, let's check around the origin. We want to see if it's symmetrical about the origin. So negative x is going to replace x. Negative y is going to replace positive y. So instead of y, I have negative y. Instead of x, I have negative x. And I want to see if when I simplify this equation, it looks like the original. So negative y, let's leave that alone. Negative x cubed, we said, is just negative x cubed. Multiply both sides by negative 1, and we get y equals x cubed. That is our original equation. So this is good. This means it is symmetrical around the origin. So this one was symmetrical about the origin, but not around the y-axis or the x-axis. Okay, next video to do the second equation.